In this video, we're going to look at some of the cool reactions of the aryldiazonium ions. This molecule that I've drawn here in the middle is a diazonium ion, specifically an aryldiazonium ion. This part of the molecule is what we refer to as the diazonium ion aspect, and the aromatic ring attached to it specifically makes it an aryldiazonium ion. First, let's look at how this molecule is made. This is synthesized very easily from aniline, reacting aniline with sodium nitrite, NaNO2, not NaNO3, in acid, HCl. That will synthesize the aryldiazonium. And the aryldiazonium is able to do a lot of really cool reactions that we can't do on normal benzene rings with electrophilic aromatic substitution. I'm going to draw 8 of those reactions here. So the first one I'm going to draw, if we use our, if we use our aryldiazonium with copper bromide, CuBr, this will give us a brominated benzene ring. I guess that's not too unique because we already know how to do that. Or if we use copper chloride, CuCl, this would give us a chlorinated benzene ring. That one also, I guess, is not necessarily that cool. If we use CuI, copper iodide, copper 1 iodide, we could get an iodobenzene, which is kind of neat. Another cool reaction, if we use copper cyanide, CuCN, that is going to give us a benzene with a nitrile group on it, which is pretty handy. And that nitrile group, we can do a hydrolysis. So with H3O plus and a little bit of heat, we can convert that to benzoic acid, just by the standard conversion of a nitrile to benzoic acid. We've got a few more reactions to go. We could put a fluorine on here. This is going to use different reagents, so no more with the copper. HBF4, and we get ourselves a fluorinated benzene. We could put water on there, so this would synthesize a phenol. H2O with heat is going to give us a phenol. We have, I gotta be careful about my space here because I've got 2 more to go. With this reagent, H3PO2, we could take that aryl group right off of the benzene ring if we wanted to. It's not the only way that we know how to strip the functional groups off of a benzene ring. And then last but not least, and this one is actually really cool, if we react this with another benzene ring that has some kind of random group on it, I'm going to call it R for now, and I'll make a list of what R could be. We're going to end up with a coupled molecule. So the aryl or the diazonium group is going to stay put, and we are going to attach this second benzene ring to the other side of the diazo group. This is a type of molecule that could be used to synthesize dye, different colorings like that. Got to make myself even a little bit more room to get that R in there. A very large, very conjugated molecule. So these molecules are usually very colorful. And let me make a list of all of the different things that R could be. R could literally be what we would normally use the R to abbreviate, which would be an alkyl group. R could be an primary amine, an NH2. It could be an OH group or an OR group, or it could be an ester. Let me move this up like that.